welcome. I'm Dr. Pauline Fu. In this video, I will introduce how to organizing and summarizing data. So in talking about summarizing data, we'll distinguish between qualitative data and quantitative data. For qualitative data, we usually use frequency distribution table, bar chart, pie chart, etc. And for quantitative data, we have much more tools and techniques to organize and summarize the data. So let's talk about qualitative data first. Qualitative data. Usually we organize qualitative data in a table we call frequency distribution table. And sometimes we also need to calculate relative frequency. It is just a ratio between frequency and total number of objects. Okay. And we are going to use Excel to construct bar chart, pie chart. So that is the qualitative data. Now, let's look at an example. Suppose you have a bag of candies. The candies have different colors: brown, yellow, red, orange, blue, red. And you count how many of the candies are brown, which is 12. How many candies are yellow? 10. How many candies are green? 5. So you organize in this table. That is the frequency table. Okay, count how many objects. And you can also display that table in a bar chart. So for brown candy, you have 12. Yellow candy, you have 10. Okay, 10. And green, you have 5. Green, you have 5. So the x-axis represents different colors of candies, and y-axis represents the frequency. Parental chart, it is a kind of bar chart, except we arrange the frequency from highest level to the lowest level. In this example, they actually created relative frequency. They use relative frequency as a vertical axis, y-axis, okay? And how do you calculate relative frequency? So go back to this table, okay? So how many total candies? 12 plus 10, 22. 22 plus 9, 31, 37, 40, 45. Total you have 45 candies. Okay, so relative frequency, use 12 divided by 45. Okay, you get a number. So what is that number? Let me use the Excel. Quickly do it. So we want to calculate 12 divided by 45. Okay. And the result is 0.266. Similarly, you can do the frequency, relative frequency calculation for others. So for yellow, 10 divided by 45. Okay, 10 divided by 45. Okay, so and oops, 45. So you get the idea, okay? So this is the relative frequency. How do you get those decimal places? Sometimes when we organize qualitative data, we need to compare two data sets. For example, this table represents the marital status in millions of US residents 18 years of age or older in year 1990 and the year 2006. The question asks you to join a side-by-side relative frequency bar graph of the table. I will maybe just move my table a little bit, which is too sunny here. Okay, maybe this is a better place. Yes, it looks like it is all right. So let's continue. All right, so I'm just adjusting my table so that the sound will not directly to my computer. All right, let's go back. So this data is about two data sets about marital status in year 1990 and 2006. Okay. So how do we draw side by side chart? Okay. So we can use Excel. So this is the data. Okay. So you select the data range first. And then you go to insert on the menu bar. Oops. Just ignore this. It asks me to update the office. So insert. Insert. Bar chart. And then clustered column chart, the first one. Click this command chart. Okay. So click the first one, clustered column chart. All right, so you get this chart, okay, compare two sets of data. The blue represents year 1990 and orange represents year 2006. So that is the side-by-side column chart. So far we talked about qualitative data. We use frequency distribution table. We use bar chart. We can also use pie chart and other graphs to represent qualitative data. Next, we'll turn to quantitative data. So we'll talk discrete data, create histogram for discrete data, and how do we organize continuous data, create histogram for continuous data, and then construct stem and leaf plot, construct dot plots. Finally, we'll identify the shape of distribution. Let's look at this example. This data represents the number of available cars in a household based on a random sample of 50 households. Construct a frequency and relative frequency distribution table. Okay. So let's interpret some data first. So this number 3 means this household has 3 cars. This 0, the other household have 0 car. And this one household have 1 car. This is one household have 2 cars, etc. And total, how many households are invested? 50. So we can create this table to summarize, to organize and summarize this data here. We count how many households do not have car or have 0 cars. There are 4 families. How many have 1 car? 13 families. How many have 2 cars? 22 households, etc. Okay. And the total, if you add all these together, total we have 50 households. The relative frequency we already introduced. You use frequency divided by total number of objects. In this case, it is 50. So every number here divided by 50, you get relative frequency. Relative frequency. And then you can create this frequency and relative frequency table. Once you have this table, you can use Excel to create a histogram. The difference between histogram and column chart is that you notice this is a histogram. There is no space between each column. See, there is no space. Okay, 0 space between each column. The difference between this graph, this is just the frequency graph, okay? And this one is a relative frequency. When you have relative frequency, this y-axis, usually it is a decimal numbers. So this is another example. So before we go another example, let's introduce the new concept, classes. Classes are categories into which data are grouped. When a data consists of a large number of different discrete data values, or when a data set consists of continuous data, we must create classes by using intervals of numbers. So for example, this table represents the number of persons aged 25 to 64 who are currently work disabled. The number is in thousands. The age from 25 to 34, okay, 2,100, 32,000 people are work disabled. Between the age group 55 and 64, 5,108,000 people work disabled. And in this table, we call those numbers 25, 35, 45, 55 lower class limit. And we call this number here 34, 44, 54 upper class limit. And class weights is the difference between 2 consecutive lower class limits. So class weight equal to the difference between 35 and 25, 2 consecutive lower class limits. That is class weights. In this case, 35 minus 25 is 10. 10 is the class weights. Generally, we can calculate class weights using the largest data in the data set, subtract smallest data in the data set, and divided by number of classes. So that is the table display. Using interval, those are the interval. This 8 is the interval here. Next, look at the stem and the leaf display. Okay. This graph, there is a vertical line here. On the left-hand side, it is you have some whole numbers. Right-hand side, you have many single digits. So this number here, it is actually represent 28. 28. And the next one, you have 38. Okay, 38 again, there's an 8 here, 38. And then 38. And then followed by 33, 33, 39, and then 32 here, 32, 32, then 39, 32, 32, 32. And the last one is also 32. Okay. So this last number here represents 85. Okay, this 85, and this is 75. So this is the stem and the leaf plots to organize and summarize the data. This is another example. Okay, stem and leaf plot. Next method for displaying quantitative data use the dot plot. Dot plot. This example is based on number of cars in household. Okay, so remember that example, number of cars in household. How many households have 0 cars? 4. How many households have 1 car? 13. So we can use a dot plot to represent those data. Oops, dot plot. Here, so we say there are 4 households has 0 cars. So we use 4 dot in vertical direction. There are 13 households have 1 car. So you put 13 dot in this direction, etc. So this is the dot plots. And once you have either stem leaf display the dot plot, they have the pattern. For example, if you turn this stem and the leaf 90 degrees, oops, you can see the shape of the distribution roughly is this if you turn 90 degrees. Okay. And for this dot, if you make these connections, you have a shape. Okay. Generally, we have 4 different distribution shapes. One is uniform distribution. Okay. Uniform, symmetric. Okay. And the second one is the popular one, bell-shaped symmetry. Bell-shaped symmetry. And this one is skewed to the right. You have a longer right tail. And this one skewed to the left. You have a longer left tail. So any data sets, when you summarize them in stem leaf plot, dot plot, or even frequency distribution table, you can see the pattern. okay, belong to one of those patterns. So next one is additional displays for quantitative data. Polygon plot, okay. Again, frequency distribution table, algebraic curves, time series graph. So let's take a look at this example. This example is about volcano eruptions, the time between eruptions. Based on historical data, you found the time between eruptions from 670 seconds to 679 seconds occurred 2 times. And the time between eruptions from 680 to 689 seconds, the frequency is 0, etc. Okay. So once you have this interval data, you can calculate class midpoint. Class midpoint, it is just the average of the consecutive lower number. So 670 plus 680 divided by 2, you get 675. And how did you get 685? 680 plus 690 divided by 2, you get 685. That is the class midpoint. Okay. And you can also calculate relative frequency here. Remember, how do you calculate relative frequency? First, you add all frequency, get the total here. Okay. So total 45. Okay. Okay, if you add all this number 45, and then you use 2 divided by 45, you get 0.044. And how do you get 0.1556? You use number 7 divided by 45. Okay, so that decimal place we call relative frequency. And then you can construct a polygon graph. In horizontal line, you take the midpoint. So 675, 685. See, 685, 675, 665, 675, etc. Take the midpoint. And vertical axis frequency. Okay. You can, those are the frequency as y, okay, vertical axis. And you then connect those dots. You get polygon graph. Similarly, you can construct relative, based on the relative frequency table. So next one is the algebraic curve. Algebraic curve is based on cumulative relative frequency. Okay. So first, we already know what is the frequency, what is the relative frequency. Let's talk about cumulative frequency. Cumulative frequency means for the first one, it is just 2. The second one, you need to add these 2 numbers. That is 2. And this number 9, you need to add the first 3 numbers. So 2 plus 0 plus 7 equal to 9. And how do you get 18? You plus all these 4 numbers. 2 plus 0 plus 7 plus 9, you get 18, etc. So that is the cumulative frequency, okay? And the next one, cumulative relative frequency. How do you get 0.044? you use number 2 divided by 45. Okay. And how do you get 0.2? You use 9 divided by 45, etc. And you get cumulative relative frequency. And then you use this cumulative relative frequency as y-axis. That is the graph here. Cumulative relative frequency here. Cumulative relative frequency. Okay, and for x-axis, you use the midpoint. Okay, so that is the algebraic relative frequency algebra. And this one, the difference between cumulative is, for the cumulative, you use a cumulative frequency here. You use this column as y. Okay, cumulative frequency, you get this first graph. If you use cumulative relative frequency, you get this second graph. So that is the algebra curve. Last one, in this video, we'll introduce time series data. Okay. And this data is an example of closing price of Dow Jones Industrial Average from year 1990 to year 2007, the closing number. So how do you construct a graph? So you go to Excel, okay, and you just select this data, and then you go to insert, graph, and then you select line chart. Maybe this is insert. Just click this line chart here, and you will get this line chart here. And see, this is the line chart. All right. In summary, what we did in this video, it is actually in the first slide. We organize and summarize qualitative data. What tools available for qualitative data? We use tables, bar chart, pie chart, etc. And we also did summarize and organizing quantitative data. Those are the list of all the tools of summarizing quantitative data. Okay, we can use a table, frequency distribution table. We can use sum and leaf plot, dot plot. Okay, and we can use a polygon, relative frequency distribution table, algebraic curve. Last one, time series data. Okay, all right. That's all for this video. Thanks a lot for watching. Hope you enjoyed the beautiful day. Okay, see you next time.